Hey everyone, this is Hareesh Iyer. I'm a solutions architect with AWS. And today I want to talk about how you can transform monolithic applications into microservices. Here is a high level agenda. I want to start with giving you a basic introduction to microservices and talk about some of the key principles behind microservices. Then we will do a compare and contrast between monolithic architecture and microservices architecture. And my goal there is to give you a mental model around how to choose between these two architecture patterns. And then we will dive deep into how you can take a monolithic application and then refactor or transform them into a microservices architecture. Let's get started. So let's start with the question of what are microservices. One of the definitions I really like comes from Sam Newman, who is the author of a popular book on microservices. It's called Building Microservices. According to Sam Newman, microservices are small, autonomous services that work together. That definition sounds simple, but it has many layers to it. So let's try to unpack that a little bit. First, microservices should be small enough so that a single team can build, test, deploy, and manage that. The size of the team really depends on your organization. I work for Amazon, and here we have a concept of 2-pizza team. The idea is that you should be able to feed a team with 2 pizzas. But your organization may have a different team structure. But the idea is that microservices should have a small enough scope for a team to manage it. Next, microservices should be autonomous. Means that a team that owns this microservice should be able to make a change, test, and deploy that into production whenever they would like without impacting the other microservices. One of the key aspects of this well-defined boundary or self-contained nature is the fact that microservices have their own data store and they don't share data stores or databases with other microservices. And the last part there is that the microservices should have well-defined contracts through which they work together. These are network calls, preferably loosely coupled. You might have heard about the concept of event-driven architecture. We would like these microservices to be loosely coupled, but they should have a clearly defined contract through which they work with each other to deliver a business capability. So going back to the definition, microservices should be small enough for a single team to own it. It should be autonomous, that any changes that's happening to this microservice should not impact the other microservices that are running. And they should all work together to deliver a business capability. That said, are microservices a better architecture pattern compared to monoliths? The way I look at that question is very similar to asking which box to choose to ship the choice between a square box or a rectangular box really depends on the dimensions of the content that I'm shipping, right? And the size and other things as well. So to me, the choice between microservices and monolith really depends on what business challenge that we are trying to solve. One of the main reasons why many organizations adopt microservices approach is the fact that it can improve the time to market. It can improve your agility. You can innovate faster. If you have to make a change to a monolithic application, you have to make sure that you test the entire application, making sure that nothing is broken, and you have to often coordinate with multiple different teams to roll that out into production. Back in the days, I used to support a monolithic application, and I remember we had 4 or 5 releases a year. I remember going to the office on Saturday evenings, often with a sleeping bag, and wait until right after midnight for the application to be brought down, to deploy the new version, and hoping that nothing breaks in production. Because if something is broken, you have to make a change and go through the entire regression cycle to make sure that the application is stable before you can safely roll it into production, right? With microservices, you are limiting the impact of your changes. Since each microservice can evolve independently, you should be able to create changes and roll out new features in a faster pace. Microservices also can improve application scalability. Let's think of a scenario of an e-commerce application where you are launching a new product or upcoming product, which is not yet in the market. If it creates interest, many people might be coming to your e-commerce site and browsing through the product, looking at the details. So there is a specific set of functionality where the traffic suddenly spikes. If you have a monolithic application, you'll have to plan to scale the entire application. But with the microservices approach, if you have designed it properly, you may have a single microservice that handles this product selection or product browsing functionality, and you can manage the scaling just for that particular one microservices. So that's a much more efficient way to manage scaling required for your business capability. Microservices can also improve your fault tolerance. If you have a monolithic application and if something breaks as part of a rollout or maybe as part of any other configuration change, it can potentially bring down the entire application. With microservices approach, your incremental change is limited to a specific microservice, right? So even though there may be an impact to the end user experience, your application may still be up and running, and many of the features can still be available, right? So those are all reasons to move from a monolithic to microservices approach. But be aware of the complexities that comes with such a transformation. First thing is that monolith to microservice transformation is not just a technology change. It's also a people process change. Think about a scenario where you have an application, monolithic application, and you have a development team and you have a production support team or an operations team. Now, when you're breaking down that monolithic application into 10 or 20 microservices, you now have 20 deployments to manage. You now have 20 CI/CD pipelines to manage. You have 20 sets of logs, metrics, and traces to manage. If your production support team stays the same, if you're not touching the team structure, then there is no way they can scale to meet this new technology change, architecture change. So often you hear the term DevOps with microservices. So you need to align your teams around these microservices so that they can own the entire life cycle of the microservices. Next, one of the key principles of microservices is that each microservices have its own data storage, right? So many cases may be replicated across multiple microservices. That comes with the complexity of keeping the data consistent across these data stores. It's easy to say, put it on paper, but to implement data consistency across multiple data stores is extremely difficult. As I mentioned previously, you also need to think about the observability. Now, with change to a microservices approach, you have many different log streams and metrics and traces coming from all these different microservices. Unless you have a solid monitoring platform which pulls this together to give you like a holistic view of the business, it's very hard to troubleshoot any kind of problems that you might be seeing. And last but not the least, if you don't come up with a clear bounded context or functional boundaries for your microservices, you may end up building a distributed monolith. And this is a place where you don't want to be at. A distributed monolith is where you have split a monolithic application into multiple services which are running in a distributed fashion, but there is tight coupling or tight dependency between these services that you have to start orchestrating them to deliver the business functionality. With a distributed monolith, you are going to get all the overhead and trouble of managing microservices, but you're not going to gain any kind of benefits that a microservices approach can provide. So you definitely don't want to be here. You'll hear a lot of success stories. If you listen to the talk around microservices, you'll hear a lot of organization moving from monolith to microservices. But there are also companies moving from microservices back to monolith. This comes from Amazon. Amazon Prime Video moved one of their monitoring platform from a microservices approach back to monolith. And by doing that, they were able to achieve higher scale, resiliency, and reduce their costs. To be completely transparent, Prime Video runs many of their applications in a distributed microservices architecture. But they also found situations where microservices were not the right fit for them, and they moved back to monolith to address that business challenge. So I want to wrap up this question of microservices versus monolith. Don't consider monolith as legacy or technical debt. It's just a different architecture pattern compared to microservices. And the choice between microservices and monolith really depends on what business challenge that you're trying to solve. Neil Ford in 2015 came up with this book called Evolutionary Architecture. And this quote comes from Amazon CTO Werner Vogels, who says that pretty much the same lines of evolutionary architecture, saying that you have to be open to evolve your architecture to meet the demand. Architectures are not set in stone. These are not immutable artifacts. You may start as a monolith, start building a monolith, and as the business needs, requirements change, you may break them down into microservices. And at some point, if all the business goals are met, some of these functionalities may still remain as monolith, some may be microservices. So let business requirements drive your architecture and make this software systems a strategy, not a religion. Now that we covered the fundamentals, let's look at how you can transform a monolith into microservices in a structured fashion. I recommend you follow a 3-step process here. The first step is to decompose your application's business domain and identify self-contained capabilities that you can build your microservices around. Once you identify these capabilities, business capabilities, you can start modernizing or refactoring the monolithic application. For this step, I recommend you consider strangler fig pattern, and we're going to dive a little bit deeper into that topic in the next section. Once you cover the first 2 steps and start refactoring, start modernization, you need to start thinking about automating this so that you can repeat this modernization in a consistent fashion across your organization. So let's start with the first step, which is decomposing your application. Your goal in this step is to understand your application's business domain and subdomain. Once you know your application's business domain, you can start thinking about how you can break it down into smaller, isolated capabilities. So how do you do this? For this, we can leverage the principles behind domain-driven design. Domain-driven design, this book was written in 2003 by Eric Evans. So this came at least a decade before the concepts of microservices became popular, right? So it has been around for quite a while. What domain-driven design enables us to do is to understand your business domain and subdomain in an organized fashion. So domain-driven design helps you as a team, as an organization, to have a shared language for explaining and understanding your application's business capability. So how do you take the concepts of domain-driven design and map that to your application's business capability? For this, one of the popular approach is to use the method of event storming. So event storming is a workshop-based approach with the goal of coming up with a shared understanding within your team of your domain knowledge, domains and subdomains. This is a fairly straightforward process where the idea is to bring your application teams, not only the technical teams, your developers and architects, but also the business folks like the business analysts and your product management and the leadership, bring everyone into a single room and brainstorm on identifying the business capability. The goal of event storming, of an event storming session, is to collect and organize events which are part of your business domain. To understand that a little bit better, let's take a very simple example of a coffee shop experience. Think about the different events that happen during that process, right? So you walk into a coffee shop, you browse through the menu or the items displayed in the front, and you start ordering, right? When you place an order, the cashier there takes a payment, prints a bill for you, and then sends the order back to the barista for making the coffee, right? Once he or she is done, they're going to call your name, deliver the coffee, and then you walk out of the store. Think about the different events which are happening within the whole process. So what happens as the first step in an event storming process is everyone individually writes down their understanding of the different events as part of that occurs as part of the application flow. Once you note it down, they write it into a sticky note and stick it on a wall, right? So that's your starting point. At this point, many of the events may be repeated. Many people may come up with the same events, which is totally fine, right? If that happens, it means that that event is important and it's a critical part of your business flow. Once you have this list of events to start with, you start arranging them according to a timeline. You want to understand at what point these different events happen. This is also a time when you start enriching these events with additional details around who are the different actors who participate in this particular event. Also ask questions. What are the pain points? What are some of the additional details that we need to gather to get a better picture? So this is an iterative process. And you may also identify that some of the events may occur in parallel, right? So you draw swim lanes and collect these events together. At the end of the session, you may think that, hey, for some of the parts, we have a clear understanding and we are aligned, but for some of the other parts of the application domain, we still need further discussion. So this is not like a one-step workshop. You can always, further refine areas which needs more clarity, come back and double click on specific topics. But the goal is you as a team, both business and technical teams, come out of this event storming session with a solid understanding of what are some of the events and how you can start grouping them together. So in this process, as you iterate through it, you start identifying events which are tightly correlated and stay together, and events which are kind of decoupled, right? And this is where you can draw your functional boundaries, or we can call it bounded context. And those boundaries are potential scope for building your microservices. The other thing that you do as part of the event storming is to talk about which teams own what, right? So you also map teams to different microservices, so that way you have an understanding of who handles what. So that's the whole purpose of event storming, and this is the step one before you start building anything as microservices. This is a very critical process, and I highly recommend taking time to give enough attention and work together as a team to come up with a solid list of functional capabilities. Because if you get this step wrong, you may end up building a distributed monolith, which is not where you want to be. So once the decompose is complete, you can start building your microservices. And for this, I recommend going in a phased approach. This is a quote from Martin Fowler, who is a great evangelist of microservices pattern. This is a quote from Martin Fowler, who says that if you're trying to do a single cutover Big Bang rewrite, the only thing you're guaranteed of is a Big Bang. You're setting up yourselves for failure. Like anything else which happens in life, if you do it in an iterative, structured, phased approach, you can incorporate your lessons learned from each step towards the next step and get better at it. So how do you do it? That approach that we're going to talk about is called strangler fig pattern. Now the name was given. The name for this approach was given by Martin Fowler, and the story is like Martin Fowler went to Northern Australia in Queensland in early 2000s with family, and there he saw this giant strangler fig vines. These vines, the way they grow, they seed on top of the trees, and then they grow down from there until their roots reach the soil. And once that happens, they start growing and building this beautiful patterns out there. When they grow, they compete for resources with the parent tree, thereby strangling that parent and eventually killing it. Martin Fowler sees the phased approach in a very similar fashion, right? So you identify capabilities, functional capabilities that you can pull out of the monolithic application and start building in an iterative fashion one by one, thereby slowly shrinking the monolithic functionality that you're consuming. And eventually, if you're refactoring it completely, you will get to a point where you don't need the monolith anymore, right? And you can discard it. So that's the approach. Let's take a very simple e-commerce application example just to illustrate how things things work in a strangler fig pattern. This is an e-commerce application, as I mentioned. The front end, there is a front end, there is a monolithic backend, and a single database which stores all the data. I'm giving an example of how this can be implemented on AWS cloud, but it should be very similar pattern regardless of where you implement it. On AWS, Amazon S3, which is a object storage, stores all the front-end artifacts. You have the backend monolith running here on an Amazon EC2, Elastic Compute Cloud, and the database is a managed relational database service, Amazon RDS, and it stores all the data, right? So this is a very simplified monolithic application running on AWS. The first step to modernize this application is to identify the bounded context, right? So this is where we go back to the first step, decompose that monolithic application and identify the functional capability. For simplicity's sake, let's assume that there are 3 features that we identify from this monolith. There is an order feature, there is an inventory feature, and there is a cart, right? So the first step you need to do before you even start building your microservices is to put a proxy, a facade in between your front end and the back end. The role of the proxy is to abstract away any kind of modernization that you're doing in the backend, so that from a front end perspective, it's still talking to a single backend. So the proxy, the role of the proxy is to route the traffic in an intelligent fashion between the monolithic application as well as the microservice. So let's say we want to start with the inventory microservice. You start building them. You create its own data store, right? And its own microservice. Once you test and everything is working fine, you can configure the proxy to route all the requests related to inventory now to the microservices. All the rest of the traffic, all the rest of the logic still goes to the monolithic application. On AWS, it can look like this. The proxy in this case is an Amazon API gateway, which is a fully managed API management layer. And within Amazon API gateway, you can create routes, which can, based on the APIs, it can route to 2 different destinations. The monolithic application still stays the same, but if there is a call related to inventory, it now is routing that to a microservices layer. The microservices here is built on a serverless stack using AWS Lambda and Amazon RDS as the backend store. One thing missing in this architecture, which you need to take care, is to synchronize the data store between the microservices and the monolith. Think about this. You have the microservices out there. It is starting to collect inventory data, but your monolith still needs those inventory data for the rest of the capability. So you need to build some kind of mechanism, a queue mechanism to sync the data between these 2 data stores so that you have a consistent view of inventory data in both places. Now, if you're running these workloads in the cloud, many of the cloud data stores provide this change data capture and change streams, which you can easily plug into a pipeline to do this data synchronization. But that's a consideration that you will need to do. So once you are starting to pull the features out, you do this in an iterative fashion, right? So after the inventory, let's say you're taking the order capability, building microservices for it, right? And then updating the proxy layer to route the traffic to those 2 microservices instead of the monolith. You repeat this process until all the features are taken out of the monolith, or until your business requirements are satisfied and you're okay to leave the rest of the capabilities in the monolith itself, right? If you are completely refactoring the monolith and all the capabilities are out, now you don't need the monolith anymore, and you don't even need the proxy anymore, right? So you can simplify the architecture, and this is the final state where everything goes to the microservices and the monolith is completely gone. Again, going back to this is the reference architecture that you can see. We still are keeping that Amazon API gateway for the routing layer. And it's basically routing based on the request. It's routing to different microservices here. And you can notice that it's a polyglot application, which is one of the advantages you get with microservices. Each of the Lambda is written in a different language, and the database is also purpose built for your specific requirements. The third step there is, once you start doing this in an iterative fashion, you will need to put together a structure to automate this process. Now, going back a couple of different steps, you can see here that there is some infrastructure, there is some plumbing required for you to build this strangler fig pattern, right? You need a proxy. You need to make sure that the proxy, you define the routes in the proxy. When you are running the microservices in monolith, you also need to make sure that there is isolation between these two running. So on top of the effort required to build this microservices and refactor this monolith, you also need to think about the plumbing aspect of it, the infrastructure and the routing layers that you need for the this strangler fig pattern. One thing that if you're doing this on AWS, one thing that can help here is a service called AWS Migration Hub Refactor Spaces. What Migration Hub Refactor Spaces gives you is that it builds some of the underlying infrastructure required for implementing strangler fig pattern for you, so that you can just focus on building the services and not worrying about building the proxy, setting up the routes, building different accounts to isolate the workloads, setting up IAMs for cross-account access, things like that. So again, there are some undifferentiated heavy lifting involved in the strangler fig pattern implementation, and refactor spaces abstracts away that heavy lifting away from you, so you can focus on the business capabilities. I just wanted to include this here so that if you are running things on AWS, this is something you can consider to automate and help you, simplify the migration process, the modernization process. So that's all that I wanted to cover here. We started off with talking about microservices, defining the microservices. Then we did some compare and contrast between monoliths and microservices, and kind of gave you a mental model to think about when to choose microservices versus monolith. And then we talked about a structured approach to refactor your application from a monolithic application to microservices. Hope you found this session useful. Thank you very much for listening to my session.